right into it. Shh. Quiet, please. Okay, guys. Here's what you're doing. On an Argand diagram, plot the following. What it wants me to do, first of all, is it wants me to plot what z is. So z is 2 plus I. Oh, sorry. Z equals 2 plus I. And then it wants me to find iz. Then it also wants me to find I squared z. And then it wants me to find I cubed z. Now, you can do this two ways. The first way of doing it is like this. You multiply your original one by I. That makes sense? And then you're going to get 2I plus I squared. The I squared is a minus 1, so it's minus 1 plus 2I. Is that right? Now, to get I squared, it's the same thing as multiplying by what? What is I squared? So, you have two choices. You can multiply your last answer by I. So if you multiply your last answer by I, you'll get minus 1I plus 2I squared, which is minus 2 minus 1I. You can do it that way. Or, you can say that I squared is minus 1. What's minus 1 times 2 plus I? It's minus 2 minus 1I. You get the same answer both ways. Okay? How'd you go from I squared to I cubed? It's just another I, isn't it? So we can multiply the last answer by I. And what happens when we multiply the last answer by I? Minus 2I. And then after that, plus 1I squared, is it? Oh yeah, it's minus I squared, and that is plus 1 is what you're telling me. I'll just do the in-between step. Minus I squared is 1, so it's 1 minus 2I. Now, look what happens when I draw these out. The first one is 2 plus I. That's Z. IZ is minus 1 plus 2I. Minus 1 plus 2I. That's IZ. The next one after that, I squared Z. What's I squared Z? Minus 2 minus 1I, which is minus 2 minus 1I, and that's I squared Z. And then finally after that, the last one, I cubed Z is 1 minus 2I. Now, look what happens every time, guys. What happens every time? Can somebody tell me what happens every single time I multiply by I? Rotates 90 degrees. Can somebody make a prediction? That's I3Z. Can somebody make a prediction on where I4Z is going to be located? It's going to go back where it started. Okay? So, we've done that one. That's those ones taken care of. You just give the points. Have to do the same thing for U. So U is minus 4 plus 3I. So we'll go back down here. U is minus 4 plus 3I. I have to get IU. IU is going to be multiply that by I. Shh. Okay, guys. And it's minus 4I plus 3I squared, which is minus 3 minus 4I. I squared U, guys. What can you do with the I squared? Turn it into minus 1. What's minus 1 times U? Yeah, but U is minus 4 plus 3I, so shh. So it's going to be 4 minus 3I. And then finally I cubed U. Get your last answer and multiply it by. What's the difference between I squared and I cubed? Yeah, so if we use I squared U, we've multiplied it by I twice. I need to multiply it by I 3 times for I cubed U. So if I get the last answer and multiply it by I, what will happen? 4I minus 3I squared. And what's 4I minus 3I squared? 3 plus 4I is perfect. So look, guys, we have a good few points there now. Okay, so let's start off with this. I'll minus 4 plus 3i is located where? We'll do these in red. Minus 4 plus 3i. Anybody? Red line up here. Where's IU then? Minus 3 minus 4. Minus 3 minus 4 is IU. Then the next one after that, 4 minus 3i. 4 across and 3 down. That's I squared u. And then finally I cubed u. 3 plus 4i. And then if I did I for u, where would that be located? Back at the start. Now, you can see that they're all the same distance away, aren't they? They'd make a circle, and the one underneath it would also make a circle. Just to let you know. Now that that's dealt with, describe the position of I for z. What do we say about I for z? Same as z. So same as z. Okay, that's grand. Now, describe the transformation, which is not a rotation, that maps iz onto I cube z. Okay, guys. I cube z is down here. Can anybody tell me the location of I cube z and iz? Where are they located? Here and here. Can anybody suggest a transformation that will link one of them to the other one? Perfect. Do you know does anybody know what central symmetry is? Central symmetry means you go through 0, 0 and the same amount out the other side. So look at this line here. We go 2 down, 1 across to get to the origin. Then you go the same amount through the other side. Down another 2 and across another 1, Sean. Yeah? That's central symmetry. Why is it called central symmetry? Because you go through 0, 0, the same distance and the same slope out the other side. And that's what describes IZ to I cube Z. Okay, guys. Now, yes. What? Okay. Name the image of U under central symmetry in IZ. Now, where is U located? U is located here. Yeah? And it says central symmetry in IZ. Where's IZ located? Beside it there. Now, central symmetry would mean what, guys? Go down 1 across 3, and then go down another 1 across 3. What is the image of U in IZ? Z. That's central symmetry. Do you see the way it becomes the midpoint? If you're doing central symmetry in IZ, IZ becomes the midpoint. And you just continue the same distance out the other side. I'm going to stop it here. Now, what we have next, guys, explain why IZ and I5Z can be represented on the same point in the Argand diagram. Here's the reason right here. IZ is located here, isn't it? Now, what's the difference between IZ and I5Z? How many I's are in the difference? Sorry? There's I4 in the difference. So, what you can say is, there's I to the power 4 in the difference. What happens with every I? Each I represents what? What does each I represent? Physically, what happens? It goes 90 degrees. That's once. That's twice. That's 3 times. And finally, pay attention here, guys. People get this wrong all the time. That is 4 times. So, what you can say is, I to the power 4 represents a. I4 represents a 360 degree rotation, which means it will end up back where it started. Okay, just while we're on this, guys, what does I represent rotation wise? If I multiply something by I, how much of rotation do we get? 90. I2, 180. I3, 270. I4, 360. Now, I5 is technically 450, but 450 is the same thing as just going 90, because you end up back where you started after 360. Everybody alright with that? Okay, get rid of that last question. So, W equals 2I times U. Give a geometrical interpretation of how to find the position of W on the Argand diagram. So, what we're going to get is, we're going to get our position of, anybody see IU? Everybody see IU? IU is currently located at the point -3, -4. Does everybody agree with that? IU equals -3 -4i. Is everybody agreed with that as well? Now, what does 2IU mean? Multiply it by 2. So it ends up becoming -6 -8i. What did I do? I actually, when you're talking about U, you're correct. But when you're talking about IU compared to IU, all you did was double the distance. So 2IU is double the distance from the origin. Yeah. Now, if we're talking about U in the first place, see U. U is how much? U is -4 plus 3i. When you multiply U by I, what happens? It ends up rotating. So U started off up here. Everybody can see U. When you rotate U, when you multiply U by I, it ends up down here. So what happens is you rotate U by 90 degrees. Everybody happy enough with that? And what happens when you multiplied it by 2? It turned into was it -6 -8i. So in effect, you doubled the distance. Does that make sense? So if you multiply by 2i, you double the distance. Alright, let's try something out here. If I multiply a complex number by 2, what happens? If I multiply a complex number by 2, what happens? Anybody tell me? You double its distance from the origin. If I multiply it by 3, what happens then? I triple its distance from the origin. So it might have been there, now it's 3 times longer. Now, what happens if I multiply it by I? What happens to the complex number if I multiply it by I? It rotates by 90 degrees. So if I multiply a complex number, let's say the number is over here. If I multiply the complex number, oh wait, I need to get away from green. If I multiply the complex number by I, it rotates it 90 degrees. Everybody agreed with that? If I multiply it by 3i, what happens? First of all, it will rotate it. You multiply by the I first, and it rotates it 90 degrees. Now what happens when you multiply it by the 3? Are you looking at this, lads? It triples the distance. Is that alright? Okay. Grand. So we got the gist of what's going on there. Now, next one after that, guys, is using the diagram, explain why the modulus of U is bigger than the modulus of Z. What does modulus mean again, guys? Distance. So the modulus of Z is this long, but the modulus of U is this long. Which one's further away from the origin? U. Hence, the modulus of U is bigger than the modulus of Z. Okay. This one. Let Z be 7 plus I. W is 3 minus I. U is whatever Z is, take away whatever W is. So look, there's no excuse for not picking up some easy marks there. Remember to change the sign. -3 plus 1i, 7 plus I. We're going to get 4 plus 2i. So change that there. 4 plus 2i. And what's phi then, guys? Phi is what? Phi? What do I write down for v, guys? Z over w. And what do I have to do then to fix it? To conjugate. Nothing we haven't done a number of times, okay? So look, I'm going to take a wee shortcut with this. It's going to be 21 plus 10i, and it's going to be minus 1. On the bottom it's going to be 10, and it's going to end up be 20 plus 10i over 10. We've done so many of these. It's going to be 2 plus I. Is everybody happy with v being 2 plus I? Okay, nothing you haven't done at least 10 times before now. Okay, get rid of that. Now we're on the parts we haven't done. Now, I'm going to draw them on the Argand diagram. So where is Z? I need a bigger Argand diagram, don't I? Okay, 1 second. Shh. Mick. Now, what we get here, guys, is we got to draw these out. So 7 plus I is 7 across and 1 up. So 7 plus I, what letter was 7 plus I again? It's Z. Next one, 3 minus 1. 3 across, 1 down. That's U. Go again. 4 plus 2i for U. 4 across, 2 up. U. And finally after that, phi is 2 plus I. Now, here's the interesting one. Are any of them on the same line from the origin? So if I was to draw lines coming out from the origin, is there any 2 points that are actually on the same line? There is, isn't there? Now, what distance would you say U is away compared to V? What'd you say? Twice as long, isn't it? So, U equals K times V. And we're looking at it going, look, it's double V. Isn't that right? So, therefore, U equals 2 times V. This means K equals 2. Phi equals LU. Phi is equal to L times U. What size is phi in comparison to U? Is it twice its size or half its size? Half its size. So therefore, phi equals a half of U. L equals a half. On your Argand diagram, plot 2i cubed v and minus iv. Comment on the position of both of them. So with this in mind, guys, all I'm going to leave behind is v. Phi is the only one I'm going to leave behind. So phi is 2 plus I. Shh. Everybody happy with v? Now, somebody make a prediction for me. What does I cubed do? I cubed, what would that do to it? Now, what is I cubed on its own? It's I squared times I, which is minus 1 I. So to multiply I cubed by v, what I can do is I change I cubed into minus I. I change v back into 2 plus I multiply it out, and what I get is, I get minus 2i minus I squared, and I'm going to get 1 minus 2i. Yes, Sean? It's that section we did last time. I cubed equals I squared by I1. I squared is minus 1. So what we get here is this is 1 minus 2i, okay? Now where is 1 minus 2i in location to this? 1 minus 2i. Now, if you wanted to do it like, if you're really cheap about it, if you were to draw a circle, you can actually see that actually is the 270 degree rotation we were talking about, isn't it? So it is the rotation of 270 degrees. So you could do it graphically if you're really jammed. Okay? You could try drawing a circle and going, look, I know I3 is a 270 degree rotation, so you rotate it all the way around. Everybody still looking up, guys? Now, I also have to multiply the answer by 2. What will multiplying the answer by 2 do to me? It'll double the distance, 1 across 2 down, 1 across 2 down. And where do I end up? I end up at this number here, which is 2 minus 4i. That's all that work gone now. Okay? Now, The next thing I gotta look at is what happens to V, our starting off point, when I multiply it by minus I. When you multiply it by plus I, it sends it in this direction at a 90-degree rotation. What would multiplying it by minus I do? Let's find out. It's 2 plus I to begin with, and you're going to multiply that by minus I. No, a half the distance would be multiplying it by half. So, minus 2I minus I squared, 1 minus 2I. Where is 1 minus 2I? So instead of sending 90 degrees anti-clockwise, it's sent it 90 degrees clockwise. Does that make sense? So if you multiply by I to the power 1, you rotate it 90 degrees to the left. If you multiply by minus I, you bring it 90 degrees to the right. That's your two answers. Okay? So the first answer is, even just by looking at it, guys, the first answer is I cubed means, wait a second, I cubed means 270 degrees anti-clockwise. You multiply it by 2, which means what? You double the distance. Now, you look at the minus I, and what do you say about minus I? 90 degrees clockwise, same distance. If I wrote down minus 3I, what would that do to you? Due to the question, minus 3I, what would that do? Any guesses? Come on, guys. Alex, any guess? What minus 3I would do? If I multiplied any complex number by minus 3I, what would it do? 3 times the distance, 90 degree clockwise rotation. 3 times the distance, it's a minus I, which means a 90 degrees clockwise movement. Okay, guys. What we're going to do here, guys, is remember what we said about quadratic equations. If this is one answer, the other answer has to be the conjugate. Okay, plot them both on the Argand diagram. One of them is 2 plus 4i, the other one is 2 minus 4i. Z1 and Z2. Now, can anybody tell me what physically does the conjugate do to a number? What does the conjugate always do to a number? So, as an example, if I gave you this one, minus 3 minus 4i, and it was down here, what's the conjugate of that? Minus 3 plus 4i. So what does it do every time? Mirror image, axial symmetry. Axial symmetry means it's like looking in a mirror. The x-axis is the mirror, and you go the same distance out the other side. I'll give you another example. What about minus 2 plus 2i? Where is that located? Here. What's the conjugate to minus 2 plus 2i? And where is that located? Once again, it's axial symmetry in the x-axis. So I'll just write that down. Just a bit of extra learning there. Axial symmetry in the x-axis. Okay, so that's a bit about what the conjugate actually does from a graphical point of view. Okay, now reread the question I had earlier. Back to Z1 and Z2, and back to my question. Okay. Plot Z1 done. Is IZ1 the same as Z2? Justify your answer. Well, I'll multiply I by I'll multiply a proper I by Z1, which is 2 plus 4i. I'll get 2i plus 4i squared, which is minus 4 plus 2i. What also I did there was I rotated Z1 by 90 degrees. It's nowhere near Z2. How many more times would I have to rotate it to get to Z2? So I need to multiply by, that's I1, I2, I3. If I have the circle, if I draw the circle, it makes it really easy on me. See that? Circle makes everything easy. That's I1, That's I2. And that's I3. Or does it miss I3? I think it actually misses I3 actually. So actually won't fit into it. So sorry? My circle's off. Okay. Shh. Sorry guys. We'll check it out now anyway. I'll multiply it by I3. My I3 is the same as minus I. I multiply it out. And what I get is minus 2I minus 4I squared, which is 4 minus 2I. Now 4 minus 2I, guys, I'm actually correct. 4 minus 2I means that it will never rotate into its conjugate. Does everybody got that? It will never ever rotate into its conjugate. Is that alright? So the circle I had earlier was actually correct. While it's the same distance away, it's not 270 degrees away. Just remember that. So, are they the same thing, is what we've been asked. They are not the same thing because this is the point minus 4 plus 2I. It does not equal Z2, which is 2 minus 4I. They're not the same points. Describe a transformation that maps Z1 onto Z2. I already covered this earlier. What maps Z1 onto Z2? Axial symmetry in what axis? Axial symmetry in the x-axis will map Z1 onto Z2. This one onto this one. Okay, that's done. Now what happens then? That's done. Investigate whether the image of Z2 under axial symmetry in the imaginary axis has the same position as I2 Z1. Okay guys, what's I2 Z1? It's minus 1 multiplied by 2 plus 4I, which is minus 2 minus 4I. Minus 2 minus 4I is down here. If we were to picture our circle again, we would see that it's how much of a rotation from Z1? How much of a rotation from Z1 is it? That's 180 degrees, isn't it? Goes all the way through. 180 degrees. So, next thing you gotta wonder is, it says, what image of Z under axial symmetry in the imaginary axis has the same position as this one here? So this one here needs to be the same position as this one here. How can I relate the two of these? Axial symmetry in what axis? Axial symmetry in the imaginary axis. Get you from here to here. Is that alright? Okay guys, there's a lot in that. It's tough.